For the first time since 1999, the sky over mainland Europe is about to go completely dark in the middle of the day. Not a cloud, not a storm. The sun itself is going to vanish for over 2 minutes, and it's happening this August. By the end of this video, you'll know exactly why this happens so rarely, what it actually looks and feels like to stand underneath it, and why the very thing that makes it possible at all is slowly disappearing, permanently. So what actually happens on August 12th, 2026? A total solar eclipse is simple in concept. The moon passes directly between the Earth and the sun, and for a few minutes, its shadow blacks out a narrow strip of the planet. This year's eclipse isn't even the only one. Back in February, an annular eclipse swept over Antarctica, visible to almost nobody. But that one was a ring of fire, not a true blackout. The moon was slightly too far from Earth to fully cover the sun. August 12th is different. It's the first total solar eclipse of 2026, and the only one anyone will actually be able to travel to see. The path itself is almost absurdly remote for most of its length. It begins near the North Pole, cuts down through the Arctic and the North Atlantic, and finally makes landfall across Iceland and Spain, with just the northwestern tip of Portugal catching the edge of it. The whole path covers about 8,300 kilometers, and the shadow crosses that entire distance in 96 minutes. If you're standing in the right 180-mile-wide strip, you'll get up to 2 minutes and 18 seconds of true darkness in the middle of the day. Here's the detail that's turning this into a genuine travel event. This will be the first total solar eclipse visible from mainland Europe since 1999. That's 27 years. An entire generation of Spaniards has never seen one from home, and it shows hotels along the path in northern Spain were already selling out more than a year in advance. It's worth being specific about what totality actually feels like, because it is not subtle. A few minutes before the sun fully disappears, ripples of light start rippling faintly across the ground, an effect caused by turbulence high in the atmosphere. The temperature drops by around 10 degrees Fahrenheit in a matter of minutes. Birds stop singing. Some animals start behaving like it's dusk. Then, 10 or 15 seconds before the sun is completely covered, you get what's called the diamond ring effect. One last blinding point of sunlight breaking around the edge of the moon, surrounded by a faint glowing circle, followed by a scatter of light called Baily's beads as the last rays squeeze through valleys on the lunar surface. And then, it's total. The sun becomes a black disk in the sky, ringed by the corona, the sun's outer atmosphere, which is normally far too dim to see and happens to run over 1,000,000 degrees hotter than the sun's visible surface. It's the only time most people will ever see it with their own eyes. You'd think an event this dramatic and this predictable, since astronomers can tell you the exact second it starts, down to fractions of a second, centuries in advance, would also be common. It isn't. That level of precision isn't even a modern trick. Around 600 BCE, Babylonian astronomers noticed that eclipses repeat on a cycle of roughly 18 years, 11 days, and 8 hours, a pattern now called the Saros cycle. They tracked it using nothing but centuries of clay tablet records, and their predictions were accurate enough that the method is still one of the starting points for how eclipses get calculated today. They didn't know why it worked. They just noticed the pattern and trusted it, thousands of years before anyone understood orbital mechanics. So, the timing has been solvable for millennia. The rarity is a different problem entirely, and the reason is one of the strangest coincidences in the entire solar system. The sun is about 400 times bigger than the moon. It's also conveniently about 400 times farther away. Multiply those two numbers together, and you get almost exactly 1, which means from where you're standing on Earth, the sun and the moon appear to be almost precisely the same size in the sky. There are hundreds of moons orbiting the planets in our solar system. Not one other combination of planet and moon lines up this precisely. Ours is the only one we know of where the moon fits the sun's disk closely enough to completely blot it out while still revealing that faint corona around the edge. Every other eclipse anywhere else in the solar system is either too small to fully cover its star, or so oversized it blocks out any chance of seeing what's behind it. We just happen to live around the one planet where the numbers work out perfectly. That perfect coincidence has done more than put on a good show. In 1919, astronomers used a total eclipse to prove Albert Einstein right. His theory of general relativity predicted that gravity should bend light, meaning stars sitting near the sun should appear to shift position slightly. But normally the sun is far too bright to see any stars near it at all. Totality solved that problem instantly. Expeditions photographed the stars around the blacked-out sun from islands off the coast of Africa and Brazil, compared them to photos of the same stars taken months earlier, and found exactly the shift Einstein had calculated. A single eclipse, 4 minutes long, rewrote physics. Except the coincidence that makes all of this possible isn't going to keep working out. The moon is drifting away from Earth right now, at about 1.5 millimeters, roughly the width of a pencil lead. Every year. Scientists know this because Apollo astronauts left mirrors on the lunar surface decades ago, and researchers still bounce lasers off them today to measure the distance down to inches. As the moon creeps outward, it looks very slightly smaller from Earth with each passing century. It's such a slow drift that nobody alive will ever notice it happening. But the math has an ending. In roughly 600 million years, the moon will have receded far enough that it can no longer fully cover the sun's disk from anywhere on Earth. Total solar eclipses, the kind happening this August, will stop completely, forever. 600 million years sounds abstract until you realize what it actually means. Every total eclipse you will ever see in your lifetime is a preview of something the Earth is quietly running out of. If August 12th doesn't work for your schedule or your hemisphere, mark your calendar for one more. August 2nd, 2027. That eclipse crosses almost directly over Luxor, Egypt, and delivers 6 minutes and 23 seconds of totality, the longest anyone will see on easily reachable land until the year 2114. Astronomers are already calling it the eclipse of the century, and tour operators are booking rooms in Luxor years out. It's easy to underestimate just how much a single afternoon of darkness can move people. In August 2017, when a total eclipse crossed the continental United States, an estimated 215 million Americans watched it in person or on a screen. South Carolina alone took in 1.6 million visitors and an estimated $270 million in economic impact in a single weekend. Wyoming counted more than 500,000 extra vehicles on its roads. For several of the states along that path, it was the single largest tourism event on record. Now picture that same crush of travelers converging on Iceland, a country of roughly 380,000 people, or on small towns across northern Spain that have never hosted anything close to it. Whatever infrastructure strain the US saw in 2017, expect a louder version of it this August. One more thing before you start planning a flight to Reykjavik or Madrid. You cannot look at any part of this directly without proper eclipse glasses, except during the brief seconds of full totality itself. Regular sunglasses do nothing to protect your retinas. This is one of the only astronomical events that can permanently damage your eyesight if you get the timing wrong. So, the glasses are not optional. So, here's where that leaves us. Sometime around 4 billion years ago, a Mars-sized object slammed into a young Earth and knocked loose the debris that became our moon. Purely by accident, that moon ended up at almost exactly the distance and size needed to perfectly eclipse our sun. Every total eclipse in recorded history, the ones the Babylonians tracked on clay tablets, the one that confirmed Einstein in 1919, the one crossing Iceland and Spain this August, has depended on that same accident holding steady for a few more centuries at a time. It won't stay that way forever. It's already changing, 1 millimeter at a time, and one day, hundreds of millions of years from now, the numbers stop lining up, and it simply ends. No warning, no final spectacular last eclipse to mark the occasion. Just 1 century where the moon is finally permanently too small, and every eclipse after that is partial, forever. That's not a today problem or 1,000 years from now problem, but it does mean every total eclipse anyone alive today will ever witness is borrowed time on a cosmic accident that has an expiration date. This August, for about 2 minutes, over the Arctic, Iceland, and Spain, you can watch that temporary cosmic coincidence happen in real time, while it still can.